Hi, and welcome to Hands-On Section 4.3. We're going to go through the use of the eval command to help you navigate through structures and be able to load in lots of data. This is probably going to be a pretty quick module. I'm going to go ahead and jump into MATLAB. And we're going to be working with the data file, which is posted. We started working with before the data underscore group 3 underscore point 14. So for this, one of the complications you can get is what I'd started doing before. Let me go ahead and open up, show you the issue. Say I wanted to make a series of plots that I actually started doing these guys. Change this to 1. Say I want to do cylinder pressure plots. So I'm going to go ahead and kill this. So I showed you previously how to navigate through this. So if I wanted to make a figure that had, just to refresh your memory, there's basically 7 different Spark cases on this. Oh, don't like the indents. Recut. I would literally, unless you want to spend a lot of time learning some programming that I don't know, you have to go in and change all these 1 through 7. This, oh, better turn my hold on so my plot doesn't go away. Run this. And run it. And oh, I changed the wrong number. See how prone to error it is? I should have been changing the case number. Case 2, case 3, case 4, case 5, 6, 7. Case 2, 3, 4, 5, 6, 7. Maybe that will work a little better. Hey, there we go. Okay. So yeah, I got all 7 of my plots. That wasn't that much trouble, but if I wanted to plot a bunch of these, say I wanted to plot cylinder 2, cylinder 3, or various other things, that could be a pain in the butt. And then you also have to realize that this data file, this particular point that we run the Spark sweep on, had 7 data points. Some of them only have 3, some of them have 12 or 13 or 14 points. So you could get into an issue of having things not come out, or having a pretty big coding nightmare to have to automate these things. So one of the things you can do is use the idea of eval command. I'm going to get rid of this, get rid of this, get rid of this. So here I'm just going to clear all, get rid of the plots, do a close all. I'm going to load my data, and again, I'm just for shorthand calling data equal to the file name or the variable name that the structure exists in. And here all I'm doing is taking psil. It's easier to show it, I think, than to describe it. It's going to print out a bunch of file names. So I'm basically wanting to execute these commands. Pressure in the cylinder for case 1 is equal to data cylinder 1 CAR case underscore 01. Second element. Again, that's because I know the second element is pressure. Same thing here. But here I'm grabbing case 2, case 3, case 4, case 5, case 6, case 7. So you can see how easy that was. Let me go back to my file, and if I actually eval those commands and throw in a plot at the end, I get a nice, pretty colored plot. Does exactly what I did before. So the advantage here is, if I want to make additional pressures, say I just grab cylinder 1 here, I want to grab cylinder 2, Easy. Better call these SIL1 and SIL2. Hopefully that works. I'm not sure if it ran or not. I think it ran. Plot. There we go. I must not hit it hard, push the button hard enough or the mouse click hard enough. There I got cylinder 2 and shifted, obviously, because these, just obviously, but that's just how we've referenced the crank angle. They're back in the native crank angle from the encoder signal. So I could very easily grab any variable I want out here and very easily plot them out here. And here the key is being able to change the name of the variable here. So this is where the eval command really shines. Anything that you can think to type, you can do with the eval command. So you can see back here in the workspace, I just executed these commands, which is exactly what I would have had to have done in long form. And if I have a data file that had more or less points in it, I could very easily change this, or better yet, just go in and find a variable. Let's see what we got here. Data dot. I could go length. Data dot ECU dot header. And I know that, oh, that would be the wrong one. That would be the number of variables in that. So I need to go size. There we go, 7 and 12. So I could very easily pull off that 7. Let's just do it. Since I said it's very easy, might as well prove it. So there we go. I can very easily embed that in here. And now it'll automatically recognize any file that I drop in there. So any file I load in right here, it'll make a cylinder pressure plot for each of the cylinder traces that are available. And I could extend this to plot anything I wanted to, and essentially be able to make one single program that can basically wade through, in this case, like I said, it was 2,000 individual data points, and each one, I think on average, there were 6 or 10 different spark points, something like that. So there's a lot of data here. All of them had cylinder pressure, had emissions, the whole works, which you guys are obviously, most of you guys are at GM or a similar place. So you guys get the same level of data, if not more than what we have. So you can see we also had all the emissions embedded in here as well. So that's where I use eval a lot when I'm using structures, because you have to somehow oftentimes reference the structures, and there's just no easy way to do that in automatic fashion that's simple other than using eval. So for a mechanical engineer like me, who's not necessarily the best coder in the world, don't really want to spend time learning a lot of stuff, eval command saves my bacon, keeps me being productive a lot. So I'll go ahead and close out here, and next section we're going to talk about how to export data. Again, I think that'll be a pretty quick module, just to show you how to do save the workspace and also export to a spreadsheet file.